All right, ever hit play on a Spotify track and just wonder what happens next? Like what magic is going on behind the scenes? Well, today we're going to pull back that curtain and look at the incredible engineering that powers the whole thing. This is going to be fun. So, to even start to get your head around this, you have to appreciate the scale we're talking about. I mean, look at this number. Spotify is serving over 600 million active users every single month. That's a mind-boggling number of people all hitting play basically at the same time. And it's not just the people, right? You've got this massive library of over 100 million tracks, and the system has to process billions of events every single day. Think about it. Every time you play a song, skip a track, search for an artist, that's an event, and it all has to be handled in a blink. Which brings us to the big question, right? What really happens when you press play? From that tap on your screen to the music hitting your ears, there's this whole complex, fascinating journey. So let's follow that path step by step. Okay, section 1, the app in your hand. We're going to start right where you'd expect, with the app itself. The first big challenge for Spotify is making everything feel the same, no matter if you're on your phone, your laptop, or whatever. Okay, so this is super interesting. Spotify actually takes what they call a hybrid approach. For the desktop and web versions, they basically wrap their web app inside this really efficient little shell. It's built with web stuff, React and HTML5, which means they can update both the desktop and web app at the same time. Super efficient. But on your phone, that's a whole different ballgame. The big priorities there are battery life and pure speed. So they use native code, that's Swift for iPhones and Kotlin for Android, to get every last drop of performance. But they add a pretty clever twist for the UI. And that twist is called the Hubs framework. This is genius. Instead of the app's layout being hard-coded, the server sends it a little package of instructions that says, hey, put a carousel here, put some cards there. This means Spotify can constantly experiment and change the look of your home screen without you ever having to download an app update. It's all about being nimble. All right, next up, journey into the mesh. So we've left the app, and now we're diving into the back end. Once your app knows what it wants to show you, it has to talk to Spotify's brain, which is this huge network of thousands of tiny little services. And that creates a big communication problem. Yeah, just think about it for a second. If your phone had to make one call to get your profile, another for your playlists, another for album art, another for your friend's activity, it would just slow to a crawl. In the engineering world, they call this problem chattiness, and it's a real performance killer. So Spotify's solution is just really elegant. Instead of your app making all those calls, it makes just one single call to a special service. And that service acts like a personal shopper. It runs around to like 50 plus other internal services, grabs everything you need, packages it all up, and sends one neat little bundle back to your phone. Simple. This pattern has a name, and it's a really important one, backend for front end, or BFF. You can think of it as a dedicated middleman that shields your app from all the insane complexity of the backend. The result? Way less waiting and a much snappier feeling app. Okay, but wait. How on earth do you manage thousands of these services without going crazy? Well, Spotify built their own tool for it. It's called Backstage, and it's so good they've actually open-sourced it for everyone to use. It's basically a central library for everything, with templates and golden paths so engineers can spin up new services quickly and correctly. It's like having a map and a toolkit for their entire digital city. Okay, let's get to the fun part, the recommendation brain. We figured out how the app talks to the back end, but now for the real magic. How does Spotify know exactly what you want to listen to next? This is all about solving that huge personalization problem. So Spotify really has two ways of finding music. The first is what you'd expect, lexical search. You type in Queen, Bohemian Rhapsody, and it finds the exact text. Easy enough. But where things get really powerful is with semantic search. This is where you can search for a vibe, like epic 70s rock ballad, and the system actually understands your intent. And the engine behind this is something called Voyager, which is Spotify's own custom-built system. It literally maps out every song as a point in this huge, multidimensional vibe space. So when you search, it's not looking for words, it's looking for the closest neighbors in that space. That's how it gives you songs that just feel right, even if they have nothing in common on the surface. The tech that powers that is called the two-tower model.
Now just imagine a neural network with two big parts. One tower does nothing but learn about you, your taste, your skips, what you love, and it creates a user vector, like a musical fingerprint. The other tower analyzes every song, its tempo, its energy, its genre, and creates an item vector. And the whole system's job is just to find the songs whose vectors are the closest match to yours. That's how Discover Weekly feels like it's literally reading your mind. So the perfect song has been found. Now, for the last and maybe most crucial piece of the puzzle, getting that audio into your ears smoothly without any of that dreaded buffering. You know, for years, pretty much all streaming used a protocol called TCP. It's super reliable, but it has one big flaw. If a single tiny packet of data gets lost on the way to you, the whole stream just stops. It waits, and that's what causes buffering. Now, Spotify has moved to a much more modern protocol called QUIC. With QUIC, if one packet gets lost, who cares? The rest of the stream keeps on coming. It makes playback so much smoother, especially when you're on a shaky mobile connection. But seamless playback isn't just about the network protocol. For anyone on the free tier, there's another bit of engineering brilliance at play. Instead of your app stopping the music to go fetch and play an ad, the ads are actually stitched directly into the audio stream back on Spotify servers. This technique is called server-side ad insertion, or SSI, and it's smart for a few reasons. First, to your app, the ad just looks like another part of the audio stream, so you get this perfectly seamless transition from song to ad and back again. No awkward silence. It also gets around most ad blockers, and it lets advertisers know for sure that their ad was actually delivered. It's a win-win-win. All right, for our last section, we're going to zoom out a bit. We've seen all this incredible tech, but the truth is, none of it would even be possible without the right kind of organization. Spotify's architecture isn't just about code. It's about how they solve the human problem of building all this stuff. And it all really boils down to this famous idea in software called Conway's Law. Basically, it says that whatever system you're designing, it's going to end up looking like a mirror of your company's communication structure. Your org chart becomes your architecture. And Spotify doesn't fight this. They lean into it hard. So how do they do it? They structure themselves into these small, independent teams they call squads. Each squad owns a feature from end to end, like search or playlists. And guess what their backend looks like? Yep, a mesh of thousands of little microservices, where each service is owned by a specific squad. This lets teams move incredibly fast. And they have tools for fleet management, which is just a fancy way of saying they can push out critical updates, like a security patch, to every single service all at once, in hours instead of months. And that really gets to the heart of it all. This quote just nails it. By decoupling, by separating teams from each other and services from each other, Spotify has built a system that can handle this unbelievable scale while still being incredibly fast and agile. So as we wrap this up, it kind of leaves us with one last big thought, doesn't it? We've seen the brilliant code, the smart protocols, the crazy AI models, but maybe, just maybe, the most important part of Spotify's architecture isn't the technology at all, but the human culture that was deliberately designed to create it.